So let us look at some notation that we will be using throughout the course. So generally, I will denote a vector as x belonging to Rn. Sometimes when I want to emphasize that this is a vector, and if it is not clear from the context, I will underline it also. Then a matrix is generally denoted by a capital letter, right? So this X, capital X, could be a matrix. Then if it is just a scalar, it will be something like this, again small letters. And finally, if it is a set, I will generally use it calligraphic capital letter, right? So this is a set. The difference between vector and scalar should mostly be clear from the context, but if it is not clear, I will underline it. Then a function f is denoted as going from some set A to another set B. So both A and B here are calligraphic. So it looks something like this. So this is the domain of the function. Then from this domain, it goes to a certain set which is called the image of the function. And then the full the superset of this is the codomain. So this is the codomain. This is the domain, and this one is the image, right? So for instance, let us say that f of x is 1 by x square, right? So I might say in this case that f is from R to R, right? So it takes R values in R. So x are all real, and it gives out values in R. So the output of this function is also real. However, the domain of f may be the set of all real except when x is 0. So the domain of f does not include the 0 point. Domain of f includes all the real numbers except the 0 point, right? So this is the domain. And the image of, in this case, the image of f is basically if you put any x real, then the entire real line you can have the entire real line except the 0 point, right? So you cannot get a 0 as the output because x equal to infinity is not included in the real line, right? So the image would be, so the image of f would be the entire real line except 0. But the codomain would be, so codomain of f would be the entire real line, right? So this part is called the codomain. So let us look at another example. For instance, consider you could have an example of a matrix also. So here f takes matrix value and gives output as a scalar. So this is log determinant of x, right? So in this case, f takes matrix values, square matrix values, and outputs the real line. However, in this case, you would probably define the domain as the set of all matrices which are m cross m such that their determinant is greater than 0, because I want output as real, so therefore I want the determinant to be greater than 0, right? So this is another example of the function and its domain definition. So mostly we will be concerned with the domain, and whenever I specify a function, you have to be careful what the domain is,